Today we're going to have Mr. Dana Goward, correct? Who's the president of Resilient Navigation and Timing Foundation. The foundation is dedicated to protecting, toughening, and augmenting GPS and GNSS signals. He retired in 2013 from the U.S. Federal Senior Executive Service at the nation's Maritime Navigation Authority, with 12 business lines budgeted at over $1.3 billion a year. Mr. Goward has represented the U.S. at the International Maritime Organization, the UN Anti-Piracy Working Group, and other international forums. A career Coast Guard officer among his many assignments with the command of the U.S. of the Coast Guard's air station in New Orleans and a leadership of the nation's boat operations as the first chief officer of boat forces. He has been recognized as a father of the Coast Guard's helicopter rescue swimmer program, and he retired from uniformed service as a captain in 2003. Today he's going to talk to us about the history of GPS spoofing.
Well, thank you very much. And first of all, I would like to thank George and all of you very, very much for giving my wife and I the opportunity to drive across Washington, D.C. during rush hour up here into Maryland. No, I'm serious because for the past 5 or 6 years, I've been working mostly from a home office, and I had forgotten what it was like to commute and put up with rush hour traffic. So so it's really given me a great appreciation for the retirement and working from a home office. And in recognition of this great appreciation that you have given me, I am going to forego the $5,000 honorarium that you normally give speakers and ask you that you use it for your scholarship fund or something like that. So thank you very much. The Resilient Navigation and Timing Foundation is a scientific and educational charity. With that, I think we'll just pop into the presentation.
Sound the general alarm. Court 20.
Are they insane?
Sir, the Chinese pilot insists that we are only 11 miles off their coast, and he will fire if we don't turn around and go to a Chinese port.
Send this. We are in international waters and will defend ourselves if attacked. Copy all this to the Admiralty, urgent. Are we absolutely sure of our position?
Yes, sir. An exact satellite fix.
Switch to alternate supply.
3 generators are down, sir. Flooding on foredeck aft.
So we're now down 14 degrees by the stern.
Yeoman's Center Admiralty have been torpedoed by Chinese MiGs sinking. Give them our position.
Right. Abandon ship.
Abandon ship! Abandon ship!
The last broadcast, sir.
Mr. Gupta's little trick with the encoder worked. They gave their final position 70 miles from here. The British Navy will never find them.
So as a former Coast Guard officer, I hate presentations that start with ship sinking. But this movie was in 1997, and the reason that I show it to you is because part of this presentation is to help convince you that normally what people can imagine and conceive, they can eventually achieve. And that has certainly happened here in the case of GPS and GPS spoofing. 1997. So, as I mentioned, the R&T Foundation is a scientific and educational charity, and I will give you a couple caveats. We deal mostly with policy. the system engineering kinds of policy, though. And as you may have heard, I have a background as a helicopter pilot, so not a deep technologist, and also small words, short sentences. However, that said, I have come to learn over the course of my career and in doing this something about GPS, and we do have some interesting stories that I hope you'll find worth your time about how what started as an imagination of the folks that did this James Bond movie has turned into something that pretty much happens on a daily basis and is accessible to just about anybody today. So a little bit of background and context, because systems engineers need to know where they are working and how everything fits together. So the problem here is that GPS, and of course we talk about GPS mostly as a substitute for GNSS, Global Navigation Satellite Systems, because there are several. There's the US GPS, Global Positioning System, the Russian GLONASS, the Chinese Beidou, and the European Galileo systems. They are together considered GNSS, Global Navigation Satellite Systems. But because GPS, ours, was the first, and because it was so good and so far ahead of everybody else's, it has been adopted very, very, very widely across the globe. And clever engineers have taken this highly accurate signal that is available free of charge, anywhere you can see the sky, and incorporated its timing signal and other features into a host of applications, some of which really don't need it, but they've been incorporated in it anyway. And as a result, we find that everything, pretty much everything in society, has some nexus and some dependence upon GPS. Certainly anything that is networked, because networks require synchronization, and synchronization requires highly precise time. And why wouldn't you access the GPS highly precise time that's synchronized around the globe for your network? It's free, it's good, why not use it? So as you can see, GPS is everywhere, but that's part of the problem. That's the first of the problem. As system engineers, you also know that there's another layer of complication here, and that's because not only is everything dependent upon GPS, but everything depends upon everything else. So that's caused the Department of Homeland Security to say that GPS has become a single point of failure for critical infrastructure. So what would happen if GPS went away? So there are some things that we know and there are some things we don't know. We do know that as soon as GPS goes away, immediately in the impacted area, every mode of transportation is going to slow down, makes sense, be able to carry less capacity, naturally, and it's going to become more dangerous. People who are already lost and distracted are going to be even more lost and distracted, right? The traffic's going to congest some more, and there'll be more accidents. And then we know that first responders are going to have trouble getting to the accidents because their systems to navigate aren't going to work that well. We also know that there are radio systems, for example, that use GPS timing to divide up the frequency so you can have multiple conversations on the same frequency. Those aren't going to work nearly as well. In fact, they may start working altogether. And then, because there are so many different kinds of GPS receivers and so many different kinds of synchronized clocks in so many different places, and nobody knows where they all are and what kinds what the quality is, there's no standard architecture, especially with the telecommunications mergers and disaggregations and reaggregations over the past couple decades. There's never was a standard, not even within a company, and there's certainly no standards across the nation. So at some time after we get the immediate transportation impacts, all of these clocks are going to start to desynchronize. And as they start to desynchronize, networks are going to fail. Estimates for the telecommunications network are that about a third of it will fail as soon as GPS goes away, and then about 70% or so will hang in there for about 24 hours. But you know how it is with complicated systems. The more complex it is, the more variable and unpredictable it is. So we really don't know. All we know is that transportation is going to take a hit immediately, and then after that, bad things will happen. Which order and how fast probably depends upon the phase of the moon, butterfly effect, who knows? We do know bad things are going to happen. So that's the context. That's the context we're working in with GPS. It's not just navigation. So Before there was spoofing, there was, and still is, something called jamming. It's basically denial of service, right? GPS satellites are basically very, very sophisticated clocks that transmit very, I could do this all day, very faint signals. The signals are so faint that they are weaker than the noise made by the universe humming, right? So the universe just makes more noise than the GPS satellite. So your receiver actually has to look in the noise floor for the coded signal from a GPS satellite and winkle it out there and figure out what it means. Great that it does. It's a miracle of technology. But it gives you an idea that any kind of noise in the GPS spectrum is going to, and this applies to all of the satellite systems, by the way, any kind of noise, stray noise in there is going to result in a denial of service. And of course, whenever there's something good made in the world, somebody else is going to figure out how to screw it up. And very quickly, folks figured that, wow, if I don't want to be tracked by my boss because I want to go see my girlfriend or I want to take a long lunch hour, if I think my ex-wife is following me, I'm going to buy some of these things off of the internet and make sure that there's no GPS reception anywhere near me, so my cell phone won't know where it is, or a tracker won't know where it is, and it can't report back. There was a great story in the Washington Post a year or so ago about a fellow that won a bunch of money over at the National Harbor Casino over here. Some bad guys saw him do that, and they managed to figure out which car his was, and they put a GPS-enabled tracker on it, and they followed him to home when he was taking all the money. And they broke into his house, and they stole all the money. Bad thing. Good news, though, the police figured out who it was. They went and arrested the guys, and they looked over the guy's car, and they found the GPS-enabled tracking device. They found a second GPS-enabled tracking device that his spouse had put there to figure out where he was going every day. Why would he not buy off of the internet for $40 one of these things he could put in his car? And why wouldn't that article was a marvelous advertisement for one of these illegal to use but not illegal to own devices that are really easily available. And of course, you can see they come in all sizes. And of course, the threat spectrum goes from the very low end of stray interference from servers and ill-configured antennas to the high end where Mother Nature just gets angry, and we have something like the New York City Railroad solar flare that induced such strong currents in telegraph wires that it set the offices on fire. That would probably nail some of our GPS satellites. It would certainly ionize the atmosphere and prevent the signals from getting through for a week or so. So all kinds of threats, all kinds of jamming available. We know this not only academically, but through sampling as well. Now, our nation has not seen fit to go out and find out how much GPS interference there is out there, but the Europeans have. And this next couple of slides are from a sampling that they did because they're very interested in using their satellite navigation system for tolling, revenue generation, that sort of thing. So they want to know what's going to be, who's disrupting their operations. So as you can see, just in their sampling, they found a huge number of events of interference, many of which were what they call denial events, sufficiently strong to prevent the receiver from functioning. It could be that the other events were strong enough as well, but the transmitter was just a little bit further away from where their stationary receiver happened to be. Don't know. The study wasn't structured for that. You can see that they got over 450,000 events total. And some of them were very interesting down there in the lower corner. 610 that lasted for over an hour. One that lasted 5 days. Interestingly, and certainly the case in our nation as well, interestingly, that there's no government agency that's looking for this sort of thing and going around and saying, stop that. You're interfering with this public service. We just haven't got that level of sophistication yet. Oh, and here's some information they collected at airports. Does this affect operations? Sometimes yes, sometimes not. We do have reports of aircraft not pushing back from the gate because their GPS is not synchronized, their equipment isn't working. It could well be that they push back from the gate sometimes anyway, knowing as long as they get far enough away from the parking lot, their GPS is going to start to work. Don't know. We have not had the systematic kinds of studies on this sort of thing. Only this first level of analysis. And they've shown that the jammers, over the course of the study, have not only increased in number, but they've increased in sophistication. They developed a picture book of over 300 families of GPS and GNSS interference devices in their fingerprinting. So, various qualities, of course, because they're not all UL listed. People in China that make these things don't do that. So you never know whether a small one like this is going to be effective across 100 yards or 1,000 yards. Has it been a problem? Yes, it has. And there are reports from around the world of aviation being disrupted. The graphic on the lower left there is from the advisories from the Flight Services Bureau. If you go into these places, be careful. You can't count on your GPS. Maritime, same way. This is a particularly volatile part of the world, and Maritime Administration in the United States has issued in the last year warnings and advisories, as you can see here. And the items on the left are just our, at the Foundation, speculation as to what may be the reason for the disruption. We know it's there. We don't necessarily know the motivation behind it. And we've had problems here in the United States as well. We had an instance a couple years ago where a U.S. container port was shut down for the most part for about 7 hours, apparently because a trucker with one of these personal jamming devices that didn't want to be tracked came in to pick up a container, and all of a sudden all of the cranes didn't know where they were, and they didn't know where the containers were that they were supposed to go pick up. So everything just came to a halt. Bottom one you can see there, pretty much unexplained. Interestingly, that when we talked with the wireless provider in Kansas, he said, it went away on its own. If it hadn't done that, we had no idea what to do. We had no way to figure out where it was coming from or what was happening. And we did know that it was because GPS wasn't available, but that was about it. So, and people, and while we have not had the large studies here in the United States, folks that care to take the time to look find this thing. Qualsar is a high-tech company in San Jose, as you can imagine. And this is an informal report that they gave at a little conference that we went to. And then this last one also happened in California. And it shows you how jamming can sort of morph into spoofing, because sometimes as you move into or out of an area that's being interfered with, the jamming signal can make the receiver believe that it is somewhere else, just because of, or make the receiver wander off, I guess I should say. We've had instances where there have been tests and ships have sailed into an area that's being jammed, and before all the lights go on, the receiver has said, we're headed off this way at 70 knots. A little effectively spoofing, although it's not the kind of subtle thing that you might not notice. So, 1997 was the movie, and the first public announcement or first coverage in the media of a spoofing event was not until 2011. Was it going on before that? Well, may have been. You can imagine that if someone is going to be spoofing somebody else's GPS, they probably would not want to be discovered. In this particular instance, the Iranian government was bragging about it. There was a CIA drone that was operating over in Afghanistan, and the Iranian engineers claimed that they spoofed the drone's GPS signal and caused it to come over and land in Iran. Now, I'm obligated to tell you that I've been informed by government officials that this is not what happened. And in fact, they said that in the press. However, I will also tell you that when I asked the government officials what did happen, and when reporters asked the government officials what did happen, they offered no alternate explanation. I will also point out to you that the Iranians ended up with the drone. So it got there somehow. The Iranians said they could spoof it. We know spoofing's possible. So we'll see. So in fact, not only did the government officials say it didn't happen, they said it's not possible to spoof a GPS signal. Well, the next year, Professor Todd Humphries at the University of Texas said, sure it is. Watch. And he put this remote control helicopter up in the stadium, and he demonstrated for the public how you can take over the remote control helicopter by interfering with the GPS signal. Interesting. The following year, so of course Todd Humphries did that with a drone, a dumb drone. It's all mechanical. Yeah, fine, interesting, but is it really dangerous? It wouldn't happen if there was a human in the loop. So let me see if I can make that go. Oh, you can do it. There we go.
Off the southern coast of Italy in June 2013, a 65-meter superyacht and her crew were part of an unprecedented experiment led by the University of Texas at Austin that successfully coerced the vessel off course using a custom-made GPS spoofing device. 30 miles from land, the crew's sense of the ship's location is based entirely on civil GPS signals broadcast from orbiting satellites. A UT student, serving as the attacker, commands the spoofing device to transmit faint counterfeit signals towards the ship's antennas. The attacker increases the power of the spoofing signals until they are stronger than the satellite signals, gaining control of the ship's navigation system. The takeover is stealthy. No alarms are triggered. Once in control, the attacker initiates a 3-degree change to the ship's course. The ship's navigation system reports that the vessel is drifting slowly to the left. The false location is represented here by the ghost ship. The crew applies a course correction to bring the ghost ship back onto the intended path. In reality, the ship is now on the attacker's course.
So it turns out that having a human in the loop is not necessarily a silver bullet. The crew, and in fact, the crew and the captain were expecting that this would happen. We had a similar incident during a Jemmy trial, by the way, of a aids navigation vessel that was going into a jamming area, and the crew and the captain knew that they were going into a jamming area. Just before they got all the way in, the navigation plot ran off at 70 knots in a wild direction. And then there were so many alarms and red lights on the bridge, even though they knew what was supposed to happen, they didn't really realize what was happening. They thought they had some sort of massive failure because virtually every piece of electronic equipment lit up and started beeping and had a fault. Even the gyroscopic compass indicated that it had a fault. And you think, well, why the gyroscopic compass? Why would GPS be in the gyroscopic compass? Well, so gyroscopes need to know where they are, north and south, in order to function properly. And so it has to have a latitude input. And the latitude input comes from GPS. So it's many layers of embeddedness, and you would think. Okay, so that was in 2013. And so you needed either to be a nation state or a professor with a bunch of graduate students in order to spoof a GPS signal. Not so fast. 2015 comes along. This young lady is at a hackers convention in Las Vegas, and she gives a step-by-step tutorial on how you can build your own spoofing device, and she sells little kits of parts you can assemble one from for $300. Just after that, we had our first open source report from the Department of Homeland of spoofing, or some government being spoofed. from the Department of Homeland Security, where the Border Patrol said that their drone was spoofed by the drug cartel. I'm obligated to tell you that a couple days after this report appeared in the press, the Department of Homeland Security retracted this report and said, no, that didn't happen. So we know that it's possible to happen. We know that drug cartels are very flexible, they're high tech, and that they have a lot of capability. So it'd be nice if it didn't happen. The next year, there were two, you may remember this, there were two patrol boats that were repositioning from Kuwait to Bahrain, a relatively routine mission where all they would have to do is go down parallel to the coastline of Saudi Arabia. Pretty straightforward. Somehow, rather than ending up in Bahrain, they ended up in the territorial waters of Iran. Was this spoofing? How could such a relatively routine mission turn into something that was such a huge black eye for the United States and the United States Navy in particular? Well, this was right after the agreement the U.S. had established with Iran to limit their nuclear development program. And it was the same day as President Obama's last major policy speech. And instead of President Obama's last major policy speech being on the front page, this was on the front page. And we know that there were a bunch of hardliners in Iran that were upset by the nuclear power limitation agreement. We know that Iran reportedly had ability to spoof before. We know that military GPS devices are difficult to use and often require two-person control for keying equipment in order to key them up. And then we know that military folks for routine missions will often use off-the-shelf civilian GPS because it's much easier to use and you don't have to go through the custody of the keying equipment and the awkward and difficult operations of the military equipment. I can tell you that I've been assured by government officials that this was not a spoofing incident. And the Navy report, however, the Navy report on the incident does not say that it wasn't spoofing, but it does not say what did happen. And the government officials have not offered any alternative explanation for what did happen as well, either. So, bad things happen. May well have been spoofing. We don't know. So, what we do know, though, is that shortly after that, Pokemon Go came on the scene, and that there were all kinds of incentives for the public to, one, realize that location information was important, and two, to figure out how to falsify location information. So as systems engineers, you know, it's really important to have technology. You know, it's really important to have the technology easy to use. But one of the most important things is training people on how to use the technology and getting them motivated to do it. So Pokemon Go came on the scene and really helped bring location deception to the consumer. Good on you guys. A lot of it was done through iPhone apps and other apps, but some of it was is being done by software-defined radios, which, as you can imagine, have gotten more and more inexpensive and easier and easier to use while being more and more capable. So, coincidentally, at the same time, there were reports started coming out of Moscow of folks in the vicinity of the Kremlin not being able to get an Uber or a Lyft. In fact, when they looked at their cell phone to figure out where they were, their cell phone told them they're about 20 miles away at Vnukovo Airport. So why is that? Well, a short time later, the Moscow Times had this headline, and they explained that this was a security measure for Russian VIPs, specifically the guy in the funny glasses there that don't have stems on the side holding him on his face. The idea there is that most drones are programmed at the factory to avoid airports. So if you make a drone believe that it's at an airport, it will fly away. So if you don't want your VIPs to be surveilled by or attacked by drones, just make everything around them electronically look like an airport. Now, it's not complete repression and dictatorship in Moscow not entirely anymore. And so a number of technologists decided to get on their Segways with a bunch of equipment and go around and take a look and see what might be able to make this happen, or be making this happen. And so they found that government buildings that didn't used to have antennas on them all of a sudden had these antennas on them that appeared just before all this spoofing started. And as they found the antennas and plotted out the directions in which the antennas were pointed out, they discovered that they all pointed pretty much like this, and right there in the middle of all the overlapping triangles is where Vladimir Putin's helicopter pad is. Probably not a real big surprise to anybody. So that was happening in Moscow. And then a year later, actually we at the R&T Foundation got a report from a captain that was operating in the Black Sea. Now I can tell you, my last job was as the Maritime Navigation Authority for the United States, and I had heard for years strange reports coming out of Russian territorial waters from tall ships associations and cruise lines and so on, saying, you know, there's something that's just not right with GPS when you're in Russia. And I said, well, can you be more specific and give me something in writing? Everybody that I talked to mentioned this to me, did business there, and they didn't want to make waves because they had to go back. So after I retired and we had started making folks aware of these kinds of things happening around the globe, we started getting some very interesting reports, and this is probably the most interesting one that we got. The captain was, as you can see, about 20 miles away from shore. His GPS was saying that he was on shore at an airport, and in fact, about 20 vessels that were around him, about 20, 25 vessels around him, were also having the same thing happen to them. Now, what was good about this is not only was it a written report, but we got photographs, and we got photographs of the equipment. And you can see right here on the right-hand side, and again, just a helicopter pilot, so I don't know what everything means here, but I can tell you that the signal strength for each of the satellites is suspiciously uniform. They're not all exactly the same distance from a receiver on a normally. I can tell you that the computer or the receiver there says it's navigating really, really well. In fact, its level of accuracy is maximum that it can have. It's within 100 meters of exactly where it says it should be. Some of these other numbers in GPS circles, I can tell you, are not exactly right. But this one is probably the most interesting. This says that the antenna for the ship is 39 meters under the surface of the water. So clearly something is up. So that was interesting. So we published this in Maritime Executive Magazine, some of the GPS journals, and it was an interesting phenomenon. So after that all died down, about a month later, we thought, I wonder if this is still happening out in the Black Sea. So the nice thing about maritime is that ships use something called AIS to tell each other where they are. And one of the things that we did when I was still a Fed was we put a AIS receiver into orbit on a satellite because these are all line of sight, and we thought maybe we could see where all of the ships were, and that would aid us in traffic management and maritime security and that sort of thing. And son of a gun, it worked. Well, wouldn't you know that after that, virtually every satellite that went into orbit for the next 2 years or so had an AIS receiver on it. And folks started offering this kind of information as a commercial and a free service. And this is one of 3 or 4 websites you can go onto and locate ships virtually anywhere on the face of the globe. This one, we picked this one because this one, interestingly, has these graphs of what has the ship been doing for the last day or so. And as you can see here, not only does it, there's another page that shows where it's been, but this one shows how fast it's going. So what this says is that this really, really big ship here is going about as fast as an airplane. It's about 55 knots right there, as fast as a slow airplane. And I can tell you from my experience, they would be lucky to get 15 knots together on a good day. So And this kind of acceleration and deceleration, you don't get that with a ship like that. This is all helicopter pilot level of understanding here. So pretty much anybody can see there's something going on here with this ship's navigation computations. And so as we continue to look, not all the vessels in the Black Sea had these phenomena going on, but there were quite a few. So we got together with an analytic company and found that there were about 600 vessels that we could identify that had been reporting themselves at airports. As a follow-on to this, another nonprofit that has more capability for this sort of thing than we do, C4ADS, they do illicit network analysis, looked at 2 years worth of data and found almost 10,000 instances of ships in Russian waters reporting themselves at airports. And this graphic here, you can see there's where the ships were, and then they're magically transported to these various airports. And obviously here, someone forgot to recalibrate the spoofer to a local airport and left it on the Moscow airport. So these ships were transported to Moscow here. You can see, there's always somebody that's a little asleep at the switch, right? Not paying attention to your job. So here's you can see there are some ships in the regular mooring area over here, and here are some ships that are moored in the middle of the runway at Glenfiddich Airport. A little bit more of a close-up here. You can see them being transported to Sochi Airport. There's the ships moored there. There's a different way of looking at these things. So this doesn't happen in the Black Sea. This is up in St. Petersburg in the Baltic. A bunch of ships going to the St. Petersburg Airport. There's a couple down there. And not to leave out the east coast of Russia, over here in Vladivostok. Another thing that C4ADS did was to correlate these instances with President Putin's travel schedule and draw a really, really tight correlation. Pretty much 1-to-1. So it happens. It's relatively easy to do. And it's easy to do over broad areas. It's also easy to do accidentally. So the top refers to a incident at a trade show in Portland, Oregon, and one of the vendors at their booth had left one of the outlets on the back of his test equipment uncovered. And so there was GPS signals leaking out. And within about 4 or 5 booths of a radius there, every cell phone was suddenly transported from Portland, Oregon to Toulouse, France, and from 2017 to 2014. And most of them were getting text messages out of archive from 2014 that were popping up again on their phones. Some of them were able to be recovered by taking them out and just holding them up to the sky. Some of them could only be recovered by taking them into the shop and having them completely scrubbed and reprogrammed and rebooted. So, so it just goes to show you, easy to do by accident as well. These other two are interesting also. There are many who will say, well, it's okay because, it's not just GPS anymore. We have 3 other global navigation satellite systems, and receivers are being manufactured that have chips in them so you can receive all of the signals at once. So that kind of threw down a challenge, and last year some academics said, okay, well, we can do that. And they put together for about $150. It's not real pretty, but it's a very, very functional device to spoof all of the GNSS constellations at the same time. So you're not necessarily protected there. And then, not to be outdone, some folks said, well, there is a human in the loop in a lot of these things, and they could probably tell when they're being spoofed because if they're driving along on shore, they will be able to see that the map, that the position on the map doesn't look like where they are, what they're seeing outside of the windshield. So these guys said, well, what we'll do is we will also send a fake map that kind of looks like where they are, but isn't, and helps us take them off down the primrose path to where we want them to be. And this is not trivial stuff, because we know, especially in countries like Brazil, and it's even happened in the United States, that GPS jamming and spoofing has become a real tool of organized crime for cargo theft and that sort of thing. So as we get better, as we think we have more safeguards, the bad guys and gals are leapfrogging ahead and saying, well, we can defeat that. So it gets to be a real problem. So you have in GPS spoofing a normal progression of technology from 2011 till today, where cost has gone down, capability of the equipment has gone up, and the ease of use has gone up, so that where it took an entire nation state's intelligence apparatus and technical apparatus to do it, now pretty much anyone, an informed user, I should say, can do it. So, as I said, these are not necessarily academic suppositions that we're making here in terms of the danger. We have seen it in organized crime. This is an excerpt from an article that Todd Humphries and I wrote for Maritime Executive Magazine, expanding upon his experiment there in the Mediterranean. And the idea is that there's a container ship or a tanker that's bound for Yokohama, and it's around the tip of Africa, and it's out of sight of land, and it's headed for the Straits of Malacca there. So you're not familiar, you're around Indonesia there, and you go past Singapore, and then you head back up to the Far East. It's quite a significant choke point, very, very high traffic area. We postulated, so what would happen if somehow somebody, and all of these commercial ships, by the way, they take passengers, they have empty cabins, there's only 5 or 6 people, well, maybe a dozen people on board for the crew, because they're all highly automated. So it would be reasonably easy for someone to come aboard with a relatively, suitcase or attaché-sized laptop computer and spoofing device, and effect essentially a very, very minor course correction and speed correction for the ship as it went outside of land, leaving Africa and before it got to the Straits of Malacca. So we postulated what would happen if we made those very, very slight changes, and it turns out that instead, if you do that, instead of arriving at the entrance of the Straits of Malacca on time, you arrive 10 hours early near a lightly governed area of Indonesia, and lightly governed is a euphemism for pirate land. And it's not unheard of for ships to just disappear, their cargo to be sold off, especially if it's a bulk cargo like oil or something, and for the steel to be recycled on a beach somewhere to be made into razor blades or other ships. So this sort of thing continues. We have more and more recognition by our government that this is a problem, and it's going to continue to be a problem. You can see some of you probably work in defense-related areas, and the General Accounting Office has indicated it's a real problem that U.S. weapons could be turned around and sent against U.S. targets using this kind of technology. Of course, the Department of Defense is working hard against that, but the technology is so embedded in so many things, and it's so difficult to get at them all. It continues to be a problem. And shortly after our GAO said that somebody could do that to us, the Russians in Syria, as you can see, said, hey, the U.S. did that to our drones. They turned our drones around and sent them after us. And I have not talked to a government official and not gotten a comment one way or the other as to whether or not this really happened. It is certainly possible. So, a couple more very, very recent incidents. This first one, the Geneva Auto Show, was a month or so ago. Every car in the Geneva Auto Show, Geneva, Switzerland, reported that it was somewhere in England, and that instead of it being 2019, the year was 2036. I guess it was somebody having a good time and praying a prank. I haven't seen any debrief on that one. And then this other one just actually I've had it in the presentation for a week or two, but it just broke on the news today about a company that's actually one of our corporate members spoofing a Tesla, although they showed that they could spoof the receivers in other auto drive cars as well, and they actually took over the car, scared their coworker that was in the car to death by making it go, off the road before the exit, and brake very quickly and accelerate very quickly, and that sort of thing. So where are we? Well, GPS, GNSS is very, very important. We've invested a lot of money into it, and as it turns out, that it doesn't take that much to completely undo all of our efforts. In fact, worse than undo, turn our efforts against us. So what should be done about that? Well, we at the R&T Foundation advocate for a holistic approach to making GPS, GNSS signals more secure and safeguarding their users. And this is also an approach that is advocated by Dr. Brad Parkinson, known as the father of GPS, and the President's National Positioning, Navigation, and Timing Advisory Board, of which I'm pleased to be a member. So it's protect, toughen, and augment. So we need to protect GPS signals. People are out there interfering with them every day. We need to make sure that happens as infrequently as possible. We need to monitor those. We need to monitor. Oh, there we go. We need to monitor those frequencies and have sufficient penalties for folks violating the prohibitions, such that it deters people from doing that sort of thing. We need to have better equipment. The technology, there's software and hardware out there that will make GPS receivers much more resilient to this kind of jamming and spoofing that we've been talking about. But it costs extra money, and folks are reluctant to spend the extra money in order to get that kind of security. It's starting to change, but we believe that there's a government role in encouraging that sort of thing. There's a public interest in having receivers that are using critical infrastructure and critical applications be much less susceptible to interference. And A is augment. Augment GPS and GNSS signals with non-space-based signals. The US government announced in 2008 and 2015 that it would establish a high-power terrestrial navigation and timing system to augment GPS, a system called eLORAN. You may have heard of LORAN-C, which is a terrestrial navigation system that we had in this country until 2010. The idea was to upgrade that and to pair it with GPS. It failed to do that, although the US government continues to talk about that. And in fact, we have testified a couple times before Congress. We've worked with the administration, and we've recently had legislation mandating that the Department of Transportation go forth and at least put up a terrestrial, difficult to disrupt timing signal so that there will be an alternate when GPS is disrupted. And we believe it will also be a deterrent to those who might disrupt GPS signals, because if they know that there's another source that critical applications and users can go to, and that they will not, their operations will not be affected, then they'll be less likely to target GPS signals and look around for a softer target, something easier to accomplish. Because it's really about delivering position, navigation, and timing, and not necessarily about delivering a signal from one system. This is a systems engineering approach, a holistic approach, where you have multiple sources of different phenomenology, so that if one goes out, you have others. So that's where we are, and I am very pleased to be here, and I'm very happy to take any questions you might have.
We have time for questions.
Hi there. Thanks so much for your talk. Question on your last point about the backup timing infrastructure. Was there a reason why the words terrestrial were put in the legislation as opposed to just saying we need a backup time capability? The terrestrial piece seems to like earmark it's got to be ELRAN, but just curious about that.
So it doesn't necessarily mean ELRAN, although the government has decided on that twice. And in fact, the Department of Transportation has received several proposals as a part of their request for information for non-LORAN systems to provide backup timing. The reason that it says terrestrial is because of one of the first slides where we showed where we didn't want to put all our eggs in space, essentially. And in fact, I have argued at space symposiums that, I mean, it's not just P&T. We shouldn't put all of our eggs in space for everything. You know, if we have surveillance satellites, we still need surveillance aircraft. If we have communication satellites, we still need terrestrial-based communications. Because, NASA's calculations are that we're going to have another New York Railroad or Carrington-like event from the sun. 50% probability in the next 30 years, I think, is what the numbers are, right? So it doesn't matter. Well, I suppose it shouldn't say that, but we would have to work really, really hard on everything that's plugged into a wall between now and when that happens to prevent us from having near existential damage when that solar flare comes. So we need to do everything now we can to move things from space, to augment things from space, I should say, with different phenomenologies. And so that's the deal, yeah. So, I mean, a lot of people say, well, and it's not just a spoofing thing. A lot of people say, well, Galileo or GLONASS is a good backup for GPS. Well, yes, if the problem is within the GPS system, but if it's a signal of some kind or a solar interference of some kind, well, they're all in the same frequency band and they're all going to get nailed. All of these jammers, not UL listed, most pretty broad, they get the whole thing. That said, the Russians can jam just beat GPS and send a nice little square wave and leave their system alone, but hardly anybody does that. So, yes, sir.
You mentioned another signal that would be on your, I think, second to last slide. Another signal could be used as a reference to give you some more indication that you might be jammed. Is there a way to build into a receiver a characterizer of the good signal so that if you get another signal that changes the intensity being received, that would be at least an alert that yes, something was up and you were being jammed?
Yes. All those things are possible with additional signals or even with just using a GPS signal. You can, there is software available and antennas. So there are antennas that just look at the sky and don't look to the side. Very helpful because most of the jammers or spoofers are going to be on the side. There's software that looks and says, oh, these are all suspiciously uniform strength, right? That can't be right. Or I know I was over there and there's no way I can be moving at 147 knots sideways, right? So there's software that do that. But all that stuff costs money. And the market has developed, for the most part, based on low cost. And in the absence of a real cathartic event, little Susie dying and being on the front page of the Washington Post, the tendencies or the trends that we see are people are still focusing on low price for most of the applications. Yes.
Just one other idea. Would there be a way to embed a linear recursive signal in the GPS itself so that it would, in a way, be self-synchronizing and you would know when a jam signal came in? It wouldn't be able to do self-synchronize? Because with a linear recursive sequence, without getting into crypto, you could build that with a long enough sequence that it would be pretty tough to duplicate once it had locked onto it.
So I know you were speaking English there. No, seriously. So there have been a number of proposals like that. In fact, we heard one at the advisory board 2 weeks ago for watermarking, which sounds like pretty much the same kind of idea. Yeah, and yes, that's possible. So to give you some idea of how this stuff works. So the fellow that proposed this watermarking first proposed it in a paper in 2003. Air Force Research Lab has picked it up, looked at it, and says, this is really interesting. We're going to try that on a new satellite in 2020. The author of the paper said, well, you know, we could probably do this on WAAS, which is a Federal Aviation Administration augmentation satellite system that can actually, the satellites can be reprogrammed from the ground. The problem is, the WAAS is an FAA system, and AFRL just deals with GPS satellites and the DoD doesn't tend to want to mess with purely domestic systems that benefit the Homeland. But WAAS could be modified within 6 months to do that. So the question there is kind of a bureaucratic jujitsu kind of thing. How can you make that happen and have it done in 6 months rather than trial it on a satellite in 2020? The second problem there is that it would require a Chimera. The name of the watermarking was Chimera. It would require Chimera-enabled receivers, right? And so you'd have to get all the receivers out there, and there's such a huge installed base that would be problematic. Now, there are techniques that people have proposed to provide appliques onto existing receivers in the installed base by working with the antenna feed and putting some more hardware and software in between the new antenna and the receiver through the antenna feed. All that stuff's possible, but we just don't have the political, the program, the policy motivations right now to move quickly on that sort of thing. So lots of things possible. As I mentioned, lots of hardware and software out there already, but costs money. Sir.
Okay, I got a quick question. How safe or vulnerable are the satellites themselves? Because when people talk about nefarious country, blinding one of our satellites or knocking it out or something like that and then causing disruption to the whole system.
Right. Well, so really two concerns about the satellites physically. One is from a kinetic attack, and the other would be from the sun, right, or EMP, right? Kinetic attack, clearly vulnerable. But the problem with the kinetic attack is there's 34 of them, right? And you'd have to get more than a couple in order to affect the system overall. So while that's a risk, we evaluate that risk as reasonably low. Not a whole lot of motivation for our adversaries to go after one or two satellites. Then of course there's the problem with the EMP. Again, a little bit. They could probably get a little bit more of the constellation, but still a limited number. Big problem would be from a solar event, reasonably vulnerable. The newer ones are getting hardened. I'm not sure how much you can harden them against massive solar flares. But where we see the biggest risk is in the softest spot, which is the signal. And so, we saw some of those suitcase-sized jammers there. So that would take out most of the greater Baltimore area, right? So really, why would you mess with, if you're a bad guy, Mother Nature set aside, if you're a bad guy, why would you mess with all those really hard things to do when you could send one person in with a suitcase that looks, this is a router, this is my Wi-Fi router. Okay, go ahead. And then, there are any number of scenarios with, moving it around, turning it on and off would make it incredibly difficult to find if we had the equipment in place to find it, which we don't. And somebody like that could just wreak havoc. So that's really where we see the soft spots.
Has there been any more efforts to characterize the spoofing and jamming? You presented the one case where the Black Sea and the company that did the the AIS collection and visualization. But I imagine with Google Maps and other services like that, you could get really finely detailed depiction of what's going on in the United States pretty easily if the companies cooperated with the data collection.
So you make a really good point, and something I didn't mention, part of the C4ADS report, Professor Todd Humphries again, down at the University of Texas, had a receiver on the International Space Station. He and I were both cooperating with the C4ADS in developing the report, and Todd happened to realize that he could pick up GPS jamming and spoofing, GNSS jamming and spoofing on the surface of the Earth from the International Space Station. So we have actually proposed to the National Geospatial Intelligence Agency, this is out in the open now, that this can be done from space. You have a navigation safety mission. Why don't you publish a global common operational picture of where all the jamming and spoofing is going on to allow aviators and navigators to protect themselves? Still pending. So that could be done, yes. We've had presentations at the P&T Advisory Board. Some of them, actually 2 of them, were from companies that are supporters of our charity that have said, you know, we could crowdsource this information very, very easily. You know, you could do it from cell phones. There's some personal privacy issues there. You could do it more easily from fixed installations on receivers on cell towers and networks like that. And you can get a lot of really, really good information. But we're not going to do it for free because we're in business to make money. And no one's offered to pay them to do that. So again, a lot of things are possible. The question is whether or not we have the political will and interest and motivation to do it. And so far, we don't. Sir.
With regards to electrical systems, and the fact that we're starting to have generators located all sorts of places, the phasing of the generators by letting them think they're somewhere else would be an external signal that would get into the control systems and could end up crashing the network.
Yes.
Is there anyone who is working on that problem right now that you could vector me to?
Schweitzer, so the Schweitzer Corporation.
Okay.
So Schweitzer Corporation does a lot of work with timing systems and electrical grids. So actually the electrical network is one of the last industries, electrical power industry is one of the last industries sort of come to the table on this. The National Institute of Standards has been very active over the past several years, bringing them together, helping them explore how they use GPS now, which is for forensics and billing and that sort of thing in terms of timing, and also how they're using it in terms of matching up portions of the grid in terms of the synchrophasers. So they use the phase, actually, the signal to match the phases of the 2 grids coming together. So you can imagine the better match they are, the less heat and the more efficient the matchup. The worse they are, if they're 100% out of phase, it's going to explode, right? So they're helping them understand that. It's really important in looking at all of this to see it as not just a technical problem, but it is very much a human psychology and sociology problem too, because even now, when I talk to folks in the electrical power industry, they will say, "Oh, well, yes, we do. We do use GPS, but you know, we can operate the electrical grid without GPS. We just use it for forensics and billing and some control systems and SCADA and all of that. We can't manage the grid without GPS, but we can operate it without GPS." I'm not sure what that means. I don't want to have an electrical grid that is operating but I can't manage. So I don't know. So I think sometimes we get into these self-deception things.
Well, I'll go one more and say the Internet of Things means now that spoofers could affect the load, which has to go through a very responsive control system to keep the voltage and frequency levels constant and so on.
Right.
And At this point, I'm wondering if there's a lesson there on the architecture of the electrical system that we have to start thinking about.
So I think there is. And as I say, NIST has been and you mentioned the Internet of Things. NIST has been reasonably active in this area. And in fact, it was last year and then the year before that, they issued reports which included various versions of the phrase, we don't have the timing we need for the Internet of Things. That's going to be the critical path. So that's why we're very encouraged that at this Department of Transportation timing initiative, the legislation that was passed and so forth. Timing is fundamental to everything. And then presumably, we think that, well, in fact, the legislation requires that whatever timing system, terrestrial timing system is built out, it can be expanded into a navigation system. So.
Okay, thank you, Dr. Dana Goward.
Speaking about time, yeah. Thank you very much.
Thank you very, very much.
My pleasure.